This is MATHguide.com and my name is Mark Karadimos. I'm here to talk to you today about secant secant partial lengths relationship. In this video we're going to talk about the relationship and introduce what it is secant lines are. And then we're going to get into problem 1 and problem 2. Alright, let's get to work. Well, you can see from the diagram that I have up here that we are dealing with circle relationships. So here's a circle, and we have these pieces here, and actually these are pieces of secant lines. What's a secant line? Well, a secant line is any line that intersects a circle in two locations. So you can see that I have a location here, and I have an intersection here. So this line is intersecting the circle twice, and you can see that this line intersects the circle twice also. Alright, so I have two secant lines that are intersecting, and they're both intersecting at this point right here. Alright, so how does the secant secant partial length relationship work? Alright, well, it turns out that it's a really simple expression that you could use to remember. It's the whole distance, and obviously we're not talking about the whole distance of the secant line. It's infinitely long, as all lines are. When I say the whole length of the secant line, I'm talking about from this point of intersection to the point that the two secant lines intersect themselves. Okay, so that's the whole length that I'm talking about. Okay, so the whole length times the outside length of this secant line is going to be equal to the whole length here times the outside of the secant line there. And that's the relationship we're going to use. And so that little, phrase really helps, and usually I say whole times the outside equals whole times the outside. Okay, and that's the relationship I'm going to use in the following two problems. So let's check out one and see how it's used. This is our first problem, and what I'd like to do is use our new relationship and use it on this problem. So we know we have two secant lines because this line intersects the circle at two locations. This line intersects the circle at these two locations also. Now, of course, I only have a piece of the line shown, and we're called secant lines. Alright, well, let's use our relationship, and we know the relationship is the whole distance times the outside of one secant line is equal to the whole distance times the outside of the other secant line. Alright, so let's see how it works. Alright, I'm going to start with this secant line first. So we know the whole distance is 9 plus 5, that's 14. Okay, so the whole distance is 14. I know that the outside distance is 9. I'll multiply those together. Alright, now let's go to the other chord. Now this one's a little bit harder to see because it's not exactly worked out. Well, let's see, the whole distance is going to be 6 plus x, right? It's x plus the 6. So that is x plus 6. Okay, so that's our whole distance. And we have to multiply that times the outside distance, which is 6. Now, whether we have the 6 in front of the parentheses or in the back end like it is here, we're still going to do the distributive property. I'm multiplying this term, constant term, times this binomial. So we multiply that through. Just like I'm going to multiply these two also. And when I multiply them, I get 126. Do the distributive property. 6 times x is 6x. 6 times 6 is 36. Alright, simple linear equation to solve. I'm going to subtract 36. It's the opposite of adding 36. And I'm going to get 90 is equal to 6x. Last step, I divide everything by 6. And I'm going to get my answer here. Let's see, 6 goes into 90. 15 times. And there you have it. It looks like this inside length is equal to 15 because that's x. If I wanted to know what's the whole distance here from the point of the circle all the way to the point of intersection, it would be 15 plus 6, or 21 for the whole distance. Alright, let's take a look at another example. Alright, here's our second problem. Again, we've got two secant lines. We could see one here, and we could see one right here. And they're intersecting right over here. Okay, so if we've got two intersecting secant lines, again, we're going to use the relationship that says that the whole distance of one times the outside distance is equal to the whole distance of the other times its outside distance. Okay, so let's actually use that relationship on this problem. Okay, well again, I'm going to try to do the easy one first here. So what's the whole distance here? Well, the whole distance is 10. The outside distance is 6. Okay, let's use that on the same relationship here on the other secant line. So the whole distance, well, let's see, the whole distance is x plus 7. Okay. And the outside distance is x. Okay, so let's clean it up. So 10 times 6, 60. Let's do the distributive property. X times x is x squared. X times 7 is 7x. Okay, this is different than the first problem in that I've got a second degree or a quadratic equation to solve. So the technique is different. The way you solve this one is you have to have a 0 on one side. So I'm going to subtract 60 from both sides. There's no like terms here with the 60. That's why I'm putting it way off to the side. Alright, so I'm getting 0 over here, and that was my intent. I'm putting everything here in descending order. There's no like terms. I'm just writing them all out there. Okay, now to solve a quadratic that has a 0, you could use the quadratic formula, or what you can do is factor. And it turns out that this one actually is factorable. Okay, so you could brush up on your factoring skills, but again, I would say that two numbers that multiply to be negative 60, but those same two numbers have to add up or have a sum of 7, and those two numbers would be 12 and negative 5. Again, they multiply to be negative 60, add up to be 7. Alright, so now we're going to set these two factors equal to 0 using the multiplication property of 0. Okay, so my two answers, right, if I subtract 12, I'm going to get negative 12. If I add 5, I'm going to get positive 5. So those are my two answers. Now remember, x stands for a distance. It's a length. You can't have a negative length. So this answer, well, it's not really an answer. It's an erroneous solution. We discard it. So our only real solution here, the only solution that matches the physical requirements of this problem is x equals 5. So I know that this outside distance is 5. And there you have it. I have my answer. If someone wanted to know what is the length of the entire secant length from the point it intersects the circle to the point it intersects the other secant line, it would be 5 plus 7, or 12. Even if you plopped in the 5 here. 5 plus 7 is 12. So any distance you want, we have. Alright, so that concludes this video. Make sure you go to MATHguide.com, examine our other instructional videos, interactive quizzes, and text-based lessons. Take care.